Hey, welcome back to another tutorial. This time I go over the date time and timespan nodes and using them to create stopwatches and timers and countdowns and clocks and things like that. I cover these nodes in another video where I talk about how to use them to construct date time and construct timespans, but I realized that I didn't use them to together in sort of, time-based systems, and so I want to show you how to do that. It saves a lot of time when you're dealing with complex time calculations to use these nodes, and it may not be obvious how to use them. Before I get started, I want to give you an example of where I use them and how I use them to great effect. So this here is a racetrack. I use this in a talk as part of the education and science meetings that I attend. The education and science group within NEOS talks about education, science, and research within NEOS weekly. I'll put a link in the video description to more information about this world. I actually made a separate video talking about it. But the basic principle here is when I run across the start time, it will give me the start line. I'll start a lap, and then when I come back round, I finish a lap. So you can see here that I've had... one second, the smooth POV bug. So I've got lap 4 running. Lap 4 has been running for 7 minutes, and if I go across the start line here, you'll see that lap 4 has stopped at 7 minutes, and now lap 5 is starting at 5 seconds and counting up from there. And these all use DateTime nodes and the timespan nodes to figure out the lap time. There is not a single sort of multiplication, division, or times here. There's no stopwatch node. There's nothing like that. You can use the stopwatch node, of course. I just wanted to show you how to do it with DateTime nodes, as that's the way I recommend. Let's find some space over here, and I will show you how they work. So from the previous video, you'll know that UTC now has the output of basically the current time in the UTC time zone. So you'll see it says that it's 1:46 on the 22nd of June 2020, and that's just counting up repeatedly. If I go ahead and I write this into a variable, so for that we go to variables DateTime, and then we do actions write. You can write this into a variable here. And then I've got a historical record of a date time. And this could be saved to an object or persisted for any sort of length of time that you want to. That's what's happening in the racetrack behind me. We persist a start time and an end time. I can then compare this time to the current time using things like a minus. So here I can say the current time minus the previous time, and you'll see that this outputs this pink color, which is a time span. If I click this here, you'll see that this is now counting up. So it's counting up the number of milliseconds since the previous date time here. So if I pulse this again, you'll see it restarts and it starts counting again. And all this is happening automatically. It'll handle minutes, it'll handle hours, it'll handle days, it'll handle weeks, it'll handle months, it'll handle years, it'll handle everything for you. It's just going to continue counting up from that time. So this is how I advise you do a long-standing stopwatch or timer. If you're doing something really small that only needs seconds, please feel free to use the stopwatch node. I will do another video on that one, but I just wanted to show you that these exist like this. They're also very useful to do the reverse. So to do the reverse is in to count down. What you need to do is construct a DateTime variable that is ahead of the current time in the world. So again, we're going to take a DateTime variable here. And we're going to use a write node. I'm secondary pushing to just clone the nodes here for speed. And what we can do here is we can take I need a plus node here. We can take the current time and we can add a time span to it. So if you go over here to math and then time span, and then we can do, say, time span from hours. I can say, hey, give me a time span that lasts 10 hours. And then I plug this into plus, and this will give me the value of the current time, as in this value, plus 10 hours. You can see 01:48 here and 11:48 here. So if I write that into a variable, I then have that time persisted. I can then once again use a minus, and I can say take the time in the future, so the 11:48, and minus the current time, as in UTC now, from that. And again here I get the time between those values. You can see this counts down. So this gives you a nice sort of timer for counting down. This will count down 9 hours, it will handle minutes, it will handle seconds, it will handle years, it will handle days. Please, when you're doing long-standing timers, use these timestamp nodes. If you want to format them, I've got an example over here which is pulled out from the racetrack behind me that I wanted to show off. here it is. So here I have this structured a little bit better so that it's easy to see. What I do here is I write a date time when you start the lap here. And then when you finish the lap, I write another date time variable, and those both come from UTC now. And then I minus the two together, and we get the time between the pulses essentially, and that's the time between crossing the start line. So if I start now here, and then I wait, say, a couple of seconds, so hope your day is going fine, and then we hit stop. You see that was 6 seconds of me just wittering on. And that gives us a time span, and then I plug this into the format node. I cover the format node in yet another video. This particular format node uses DateTime formatting. I will provide a link to both the DateTime formatting, sorry, not the DateTime formatting, but the format video in general below, but I'll also provide a link to the Microsoft resource for working out how this format string is structured. So for those unaware, Neos is written in C#, and so this is a C# date format string, and you can use Microsoft's own documentation on how date formatting works to figure out this string. But this here says minute, colon, second, decimal point, and then 3 digits of the milliseconds, and that's why we've got over here minute, second, and then millisecond 1, millisecond 2, and millisecond 3. That's all there is really to it. If you want to figure out if one of these counters has elapsed, you can check the time span and convert it into seconds and make sure that that's 0, or you can do various comparisons, etc. But this is how I advise that you do. Oh, not that one. I think it's that one we're using. Yeah, I've had multiple takes of this video. Yes, this is the one that, no, it is that one. There we go. That we were using to explain this video. Yes, so you can do all sorts of comparisons there. Like I said, I do recommend it in more cases than the stopwatch node. It is more powerful. It can handle, like I said, minutes, hours, days, weeks, years, etc. There you go. Check out the video description for more links, and I will see you next time.